Hi there. This is the October 2021 meeting of the Sacramento SMPTE chapter. I'm your host, Tim Walker. I'd like to remind you that this meeting is being recorded and will be posted on YouTube. So please stay muted until the end. We'll have a Q&A session with our presenters. You can also ask questions in the chat room, and we will field those either during the session or at the end. So tonight we've got Marcus Bengtsson and Stacy. They're from Disguise, and they're here to talk about extended reality and virtual production and the technology that's involved, and give an overview of the workflow. So backing up just a little bit to talk about SMPTE, we've got our SMPTE board, our chairperson Remington Maxwell, who's joined us tonight. We've got our past chair Dom Jackson, Secretary and Treasurer Mona Smothers, and the managers are Bob Huddleston, myself, Patty Leonard, Gil Mazzi, Paul Turner, and Robert Erickson. So SMPTE does a number of things. You know, we're putting out the motion imaging journal. This last month was a pretty good one, all around cloud. And we do webcasts, we do virtual courses. If you haven't done any of the SMPTE Plus stuff, that's I think it's free. Pretty good things coming out of there. We've got our blog, Newswatch, and then the Insights newsletter, and you can find access to a lot of that stuff, or all that stuff, at the www.smte.org website. We do offer a few different levels of membership. We've got the recent graduate, which, as you might guess, is for people that are just finishing up with their student membership. You get a discounted rate for your first year of individual professional membership. We've got the executive level membership, which gets you all the benefits of active professional membership, plus invitations to exclusive webcasts and more. We do have a student membership level for those that are still in school. You get networking, access to industry leaders, that type of thing, all at a very cost-effective price. Then you've got our most popular level of membership, which is the professional level. And this gets you more access with access to the motion imaging journal subscription, member only content, and the like, discounts to the conferences that we have as well. Then we've got a couple other membership options for those that have been in the industry for a while. We've got our life membership, where you have to be 65 years old and have 20 years of membership. And then we just ask you to contribute some funds to help offset some of those costs for some of the student memberships and for those who are unemployed. Then we've got also the retired level membership for those people that are retiring from the industry but still want to be engaged and participate with SMPTE. We do have those options as well. Pricing is as follows. So professional, which I said is our most popular one, is $165 per year. That's not too expensive, $12 a month, thereabouts. Then we've got the executive level, student at $15 a year, the recent grad $49, retired $89, and then there's the fan, which is people that just kind of have access to our virtual things like we have here. So without further ado, we'll go ahead and get started here with tonight's presenters. So we've got Marcus, who's the technical solutions specialist. He's based in sunny Los Angeles. And as I said, he's the technical solutions specialist for Disguise. Marcus holds a degree in software engineering and management and is a published author, award-winning engineer, inventor of several patents, and a challenger of the status quo. When he's not trying to solve impossible problems, Marcus enjoys mountain biking, rock climbing, scuba diving, good food, and good wine. He'll be joined by Stacy, who joined the Disguise technical solutions team from New Tech, focusing on cutting edge XR and virtual production technology and live production workflows. With experience in broadcast productions as a video engineer and live switcher operator, he has worked on a variety of live productions integrating cellular bonding, video transmission, IP video, switchers, and content delivery. So with that, I'm going to turn this over to our presenters and let them go. Let me stop sharing. We got that.
Okay.
All right.
Yep. I think we are good on this end.
Okay, we're now viewing the XR stage screen, which is, oh, there we are. Howdy, gentlemen.
Can you guys see and hear us?
Yes.
Perfect. Thank you for those lovely words. It's almost as if I had written that introduction myself. So it's amazing how much you could learn about me just by Googling. So thank you, Tim.
No problem.
Yeah, they even got the wine part.
Yeah, exactly. So yeah, we're standing here in our LA office on this XR stage, or virtual production volume, depending on what name you want to give it. Has multiple different use cases and multiple different applications, and those are some of the topics that we're going to be covering tonight. So first of all, thank you very much for hosting us, Tim, and to everybody who has joined us near and far. Thank you very much for staying up. And yeah, hopefully this will be informative and entertaining for all of us. So Eli?
Yeah, sure. Thank you. And yeah, thanks everyone for coming. As I mentioned, or as we mentioned in the introductions, both Marcus and myself are part of the technical solutions team, and we essentially work with our customers, work with really anyone, and kind of build out what the solution would be when they come to Disguise, which is where we work. And you know, we do a lot of different things. You know, Disguise has been around for some time, so you know, I think we play an important part in what we do at the company, trying to make sure that everyone gets the right solution. And we are definitely more technically focused, and that's what we're going to be showing you here today. Really breaking down XR and virtual production into the different components, why we use one component over another, what are all the pieces involved, and how they interact with each other. This is definitely something that I'm sure more and more people are seeing within the industry as a whole. But we're here to just kind of break it down and hopefully educate yourself and anyone you share this with as to how to properly go about working in one of these volumes, and so you're not a total newbie going into it. So with that, I think we can kind of go ahead and get started with this. I think we are going to start actually with a little bit of an understanding as to where Disguise comes from as a company. We're going to keep this very anti-sales. You know, this is here about technology, but I think it is good to understand why we are doing this, because this is actually not something that Disguise has been doing for very long. But I think I'll just jump into it and it'll make more sense.
No, so as a company, we're not young as a company. We're roughly 20 years old, so we've been doing video production in different ways for about 20 years, and actually our background is live entertainment. So if you've ever been to a concert in the past 20 years, you have most likely seen some of our work. But we think it's important to put things into context and kind of set the stage a little bit for who we are as a manufacturer and what services and products that we do provide.
Cool. So as we were mentioning, you know, this is just a very quick show reel of some of the things that we've been up to, and this is all non-XR. You know, this is just Disguise doing video playout for some of the largest and most complex installations in the world, using projection mapping, utilizing LED technology. All of these things we've been using and been around for a number of years, again, primarily within the concert touring, live events, Broadway space, some fixed installs and things like that. But it really wasn't until we started to get the introduction of augmented reality using real-time rendering engines for concert tourings or live events that we really started to bridge the gap from solely pre-rendered content and playing that out on a big screen, right? Then now going into real-time workflows where you're taking the positional data of your camera and applying that with an overlay with some sort of graphics on top of that for either IMAG for the audience inside the stadium or the people at home for the at-home production where they see that composited feed.
Exactly. And real-time content generation is something that we'll dig into in more detail later on. But yeah, that is really, I think, a good introduction to Disguise as a company and kind of how we ended up where we are right now with doing a lot of this extended reality and virtual production workflows. Is really, it's a natural progression of us as a company. Obviously, then there was a pandemic happened in the middle of this that kind of forced everybody to change their business models, and so did we. So what is it that we actually do as a company? Well, we provide two parts. We have a proprietary software that is a production management, production control, and production show control tool. This is the software that kind of runs this entire circus, right? So that's a software that can be both used on your own laptops as a kind of a pre-production / pre-visualization software, but it's also the software that then runs on the hardware that we manufacture. So we design and build and manufacture our own hardware in multiple different locations throughout the world, and that is ultimately then the hardware that is being found on film sets, in broadcast studios, and on live events all across the world. So those are kind of the two components that we provide as a company, along with multiple different integrations with third-party hardware and software that can kind of creates a sum that is greater than its parts, if you will.
Yep, and talking about the company, we have offices all around the world, and we actually got our start in London. So with our first customers being Massive Attack and U2, London headquarters is where we've always been. But we are coming to you from downtown Los Angeles, where we have our office and XR stage.
So what is actually XR when we talk about it? So the terminology is it really stands for extended reality. So the X is obviously for extended. The X can also be a wild card. It can also be kind of used to represent a generic description of quote-unquote reality technologies like augmented reality, virtual reality, mixed reality, and so on. So the X really can represent both there. But in the Disguise terminology, XR stands for extended reality. So Eli, what do we actually mean with extended reality?
Yeah, so there are really 5 main components that make up extended reality. I'm going to briefly go through them, and then we're going to kind of break down the different technologies there and really give a lot more detail as to what aspects they play within the production. So in simple terms, we have this LED volume like the one that we're standing on, the talents on there. We then have a camera pointing at us, just like you saw earlier, and we track that camera's position in real time. And so we know where the camera is, we know where the LED is, and then we render the background of a full 3D environment and put that onto the LED screen so that it looks like the talent is in this virtual environment. Then what we do is we can also add augmented reality elements if we wanted to add objects within the foreground, or if we wanted to do what's called set extension. This is where augmented reality comes in, and that's really where you get past extended reality, but that's something we'll get into in just a second. Then our workflow and other workflows really make this happen, are really a core component of technology as a whole. So let's kind of go back and start and break down these 5 components and talk about the technology that enables all of this to happen, because it really does take all of these different components to get to the place where they are now with the feature sets that they do in order to make this work. This is still very much high tech, and making sure that we're aware of the technology is a big part of this. So the first one, in-camera screens, right? So that is the LED screens that we're standing on. So if we go to our little camera up here, we can see that this is what would be referred to as a volume or an LED stage. And there are a lot of different configurations that you can see for a volume like this. So ours happens to be with a long flat wall, an LED floor that you can stand or drive cars on even. And we also have these side panels here. Now, this is just one configuration, and this is something that may be geared perhaps a little bit more for either broadcast or music video or corporate productions because of the LED floor, whereas a film production may not have an LED floor. They may use practical elements, props, and things like that into the foreground, but in replacement, perhaps use an LED ceiling so you get the lighting from above as well, with the environment being represented on the LED there. So there's lots of different configurations that are out there, and honestly, no two stages are the same. They're very customized to the space and to the production needs. So you'll see a lot of different options out there. I guarantee you no one else has the stage set up the way that we do.
Pretty much, yeah, exactly.
But there are some technologies about these LEDs that are really important to know, and some terminology around them that I think will be really beneficial if you end up working with any of these. The first of which is kind of really the defining factor and probably the biggest component or aspect about the LED that people like to talk about, which is the pixel pitch. Now, the pixel pitch is essentially the distance between the center of one pixel to another, and it's measured in millimeters. Our panels here are 2.8 millimeters, and that essentially just controls the density of the panels. If you go to a 1.5 millimeter pixel pitch, for instance, you are greatly increasing the density of the LED panels. The benefit of that is you get to have your talent closer to the LED wall. Part of that is because there is an interaction that happens when you have a camera sensor looking at a grid of any kind, but particularly with LEDs, and you get a weird artifact called moire. That's what happens. If you ever look through two fences and it has that weird wavy pattern, it's the exact same thing, and it's called moire. A tighter pixel pitch, like a 1.5, allows you to get a lot closer. And, of course, one of the big benefits of all of this is for the talent, they can look at the LED. They know the environment that they're in, and obviously a clearer or higher resolution LED panel definitely helps out a lot in that department, especially for a smaller stage. With larger stages where you're already going to be further away from the LED screen, a 2.8 millimeter panel is not bad at all, and very standard. It's actually probably the most common pixel pitch, I would say, in the industry.
I would say so too, and to that point, I think there's often a misconception in the industry that a higher resolution is always better. That is not always the case. Sure, you may accomplish a better result if you're very inflexible with the distance between the screen and the camera, but it's also important to keep in mind that every pixel has a cost, right? And that cost is kind of fixed on a per pixel basis. So the more pixels you got to render and the more pixels you need to output, the higher the cost of your entire production pipeline. So it's important to be able to make informed decisions about which pixel pitch or resolution to use early on in a production pipeline, instead of just going for the tightest pixel pitch available in order to kind of to make those informed decisions.
Yeah, and I think that really hits on one of the other core points that I wanted to talk about, which is the fact that while everyone does like to talk about pixel pitch, it is by no means the only standard you should go by. I think another one that we've encountered a lot is the color reproduction is hugely important. There is a really wide variety of LED panels that are manufactured, many of which were made for the, for instance, concert industry, where having a very accurate color space was not as much of a requirement. But now, of course, everyone's doing virtual production. Every panel that exists that's not on tour, which is all of them, are being used for volume. So you will encounter these panels that we've seen in some cases won't even hit Rec 709. Yep. So that's definitely something to be aware of as well. And we highly, highly, highly recommend camera tests, making sure that you get an accurate result there.
Absolutely.
I think the other thing that we wanted to talk about as far as the technology involved with these LED panels is the refresh rate and the scan rate. These have to do with how the LED emitters on them actually emit light, and it actually creates a really unique interaction with a camera sensor. Did you want to dive into that a bit?
Yeah,
now?
sure. What this refresh rate is pretty obvious. Like it's the amount of the number of times per second that the LED screens are refreshing their pixels, right? It's very similar to a PWM frequency on an LED light, how that works. The scan rate then is essentially a measurement of how many LEDs per panel are lit up per refresh cycle. The higher the refresh rate, the better, obviously. And the same thing with, conversely with the scan rate, you want as many LEDs as possible to be lit up per every cycle. And the way they interact with cameras is really interesting. There's a phenomenon that you may have seen where you have these wavy kind of horizontal lines moving down across an LED surface when you're capturing it in camera. And that is typically because of a disconnect between the refresh rate of the camera sensor and the refresh rate and scan rate of the LED. So that is once again an element where it's very important to do camera testing ahead of time and also being aware of what combinations of LED and cameras are expected to work well. So if we jump back real quick to our 5 components here, camera tracking is obviously one element, but the camera itself is also very, very important. We'll dig into the camera tracking a little bit later on. There's no real kind of magic recipe for something that will always work. What can be said is that you will have a greater success rate or a higher success rate if you're using a global shutter camera. They are becoming more and more common, and the reason why they are better is simply because the entire sensor will capture all pixels or all lines at the same point in time. That would just make the interaction between the LED screen and the camera sensor way more predictable. And the other element that is an absolute hard requirement is it will only work with progressive signals. We can dig into exactly why that is. And it's essentially, when using interlace, obviously the 2 frames, if you will be captured at different points in time as different fields. XR it's a game of latencies. It's a game of matching different things that happens in different points in time and make them appear as if they are at the same point in time. And that is one of the challenges with using interlace signal formats. That is very difficult to accomplish that. So if you ever find yourself in an XR setup, make sure that it's a progressive signal chain. The other hard requirement is also Genlock. That may sound obvious to all of you, but you'd be surprised how many people try to do this with prosumer level cameras that don't have any kind of synchronization. So on board the camera then is a camera tracking system. The camera tracking system is the tool that tells the XR workflow where in 3D space the camera is. And that is very, very important. Yeah?
I got to interrupt you for a second. There's quite a bit of static coming through. It might be from one of your mics.
Can improve this?
Oh, yeah.
Huh?
All right, testing.
That sounds okay. I think it might be Marcus.
It's funky.
Oh yeah, it's definitely yours. Sorry.
Oh yeah?
Yeah, you want to keep that on like your outside pocket or something?
Yeah. So it's better now?
Yes, it sounds much better.
Yes. Sounds great.
Okay, perfect. Then I will hold my transmitter in my hand. So hopefully this will be audible for all of you. So yeah, where were we? Tracking systems. What the tracking system does is provide us with a 3D position in real time where the camera exists in 3D space. And that is in relation to where the LED screens are. There are multiple different types of tracking systems. They can be categorized in essentially 3 different types. There's what's called outside-in systems, And if you've ever been in a motion capture volume or something like that, you've probably seen the setup where there are tens or like multiple different cameras that are mounted up in the ceiling around this volume. They are then capturing what happens inside that volume and translating that into a 3D position in real time. Then there's inside-out systems, which effectively work in reverse compared to an outside-in system. You have a camera on your broadcast camera, which is emitting IR light. That is then reflected off of reflective surfaces or reflective markers in the ceiling or in the floor inside your tracking area, and then once again translated into a 3D position. The third one, which is less common, but definitely something that you'll see every now and then, is vision-based tracking systems. So you can either have a stereoscopic camera, very similar to how a Microsoft Kinect would work, that essentially scans the area in real time using contrast detection and other types of technologies to translate that into a 3D position. That position is then passed on into the XR system, the XR workflow platform, and is translated into a position for the render engine to use when it's rendering the real-time content, which Eli will explain and show.
Yeah, so once we have the position of where the camera is, we're able to put that into a 3D scene. This is very similar to how you would control a camera for any sort of post-production workflow, except you're doing all of the steps in real time. So when we talk about real-time content rendering engines, there are a number out there. I would say easily the most popular amongst those is Epic Games' Unreal Engine. This is a video game engine made popular by Fortnite and other games, but it is a way to render very complex and very realistic scenes in real time, using, again, that camera's perspective as the means for controlling what you're actually seeing. Now, this same technology does apply to other rendering engines as well. It's not something that is unique to Unreal Engine, just the most popular. Other content engines we'd see would be Notch, which is a real-time rendering engine that was built around the live event space. Again, Disguise has worked very heavily with that for augmented reality, as far as like iMag and things like that. But another is Unity, again, another real-time rendering engine for video games. Both of these, or all three of those, have been used very heavily, but it essentially allows you to render the camera's perspective so you get full, very accurate parallax as you're moving the camera around, and by putting that onto the LED, it kind of marries all these things together and allows you to capture the talent and the background in camera. So you're not doing any sort of compositing or keying, and we are able to render that environment in real time. And for that, I think I'm going to actually show you one of these environments. So this is the same LED that I was just standing on, but in this case, we can see a few of the things that I was just talking about, right? So one, we have this LED, right? This is where the LED wall is right here. If I jump over to our witness camera again, you can see how that is being projected onto the wall and the floor. And as Marcus is moving the camera around, you can see how the environment is moving around with me. I think we're going to go into this in a little bit more detail later once we get some more kind of terminology and things figured out. But I did want to show you at least these three core components added right now. So as you can see, as Marcus is moving, I'm on the LED, I see the content, I'm able to interact with it, and it's all being rendered in real time, every single frame from the exact position of the camera. And so I think with that, the next component that we wanted to talk about would be, I guess, augmented reality, but I think that's a really good time to talk about the difference between XR and virtual production, because I think these are the terminologies that we see the most being used. So Marcus, you want to talk about that?
Yeah. let's hope that my audio is good now. Yes, so virtual production and extended reality they're often used interchangeably, which I personally consider somewhat of a bad practice. Virtual production is a very, very general term. It's a very broad umbrella that encompasses many, many different technologies. You can use XR workflows as part of a virtual production, but just because you are doing virtual production doesn't necessarily mean that you're also doing extended reality or XR. As an example, we typically do not consider green screen or blue screen to be part of XR or extended reality workflows. However, in virtual production, it's very, very common to use green screen instead of LED screens. Those are just two of the differences between extended reality and virtual production. There's also a difference in terms of which vertical or which world of production we are talking in. If you're talking to a filmmaker, you will most likely hear the term virtual production, or even in-camera VFX is a very, very common term. I see VFX. And essentially what that means is that the visual effects that would traditionally be created in post-production are created in pre-production, rendered on the LED screens and captured in camera. There's also the terminology called final pixel, which means that the footage that you are recording, either on tape or sending out straight on air, is actually the final pixels that are being captured from the LED screens in the camera, and there is no post-treatment done on these pixels at all. How do you think? Does that encompass some of the major differences?
Yeah, I think it does. You know, I think one thing to kind of highlight on is you were talking about how virtual production, a lot of it is about actually capturing that in camera. And that's absolutely right. But I think the big difference with XR on top of that is your final pixel essentially is not in camera. It's actually after the camera, because you have your camera capturing your LED with your talent. But as soon as you start adding augmented reality elements, that's when you need to composite on top of that camera feed. Yep. And then that's no longer being recorded in camera. So there's differences that you get with that.
Absolutely, absolutely. And we'll show you more of that later on, exactly what augmented reality means. And we've also name dropped set extension a couple of times, and we'll show that as well. So yeah, what's our next topic of conversation?
Yeah, I think the next one is talking a little bit about another common terminology thing here is talking about camera frustum. You hear this term a lot. And I think it's really important for people to understand what it is. Yep. So now that we understand where the camera is, you know, we have the camera tracking. Here we can see that camera on the right. And we also, through all these calibrations, understand that camera's exact perspective into the 3D scene and where it interacts with the actual LED panels themselves. So this red pyramid here, this perspective of the camera is known as the camera frustum, and everything inside of that is captured within the camera frustum. But when you have a camera tracking system and then it needs to be rendered, you know, there's inherently delay in that process, which is behind the camera actually physically moving and capturing a new part of the LED screen. So part of this is often including what's called a camera overscan. Essentially, you know, a 50% or whatever percentage increase in the actual size of what the camera is seeing, so that when the camera does move, it's still capturing its perspective, just with a little bit of buffer room. Then what we have is the outer frustum. So this is everything that's outside of the camera's perspective. The camera will actually never see these pixels that are being rendered on the LED. It's really there for talent context. So when the talent's standing on stage, even if the camera's really zoomed in, as shown in this example here, the rest of your LED screen isn't just black. It's still showing the environment. The talent still knows where to look. They understand where they are and they have context for that. But of course, you also get great lighting and reflection benefits of this. If you have your camera really tight and the rest of your entire 360 volume with your LED ceiling is all still rendering that environment, it really adds a lot to the lighting that is presented onto the talent, and is a really core component of this. I think the only thing that isn't listed on here is augmented reality, but as I mentioned, that's composited after the fact, just as a 2D plate. But this is some of the core terminology that I think is really important to understand, and you'll hear this a lot. The frustum. Yeah.
Indeed. And also to that point, like right now we're talking single camera, right? So we only have one camera here that is active, and as you see on this screen, there's only one camera that is rendering its frustum on the LED screen. It is entirely possible to do multicam shoots as well. You can either have a workflow where you're switching between active cameras, and when you switch from camera A to camera B, you would also switch essentially which frustum is rendered and visible on the LED screens. But it's also possible to do simultaneous frustums on the LED screens, either by carefully controlling the camera operators to make sure that the frustums do not overlap, because obviously then one camera will see the other camera's frustum and so on. But there are also technologies out there that is mostly controlled by the LED processor manufacturers that will allow you to have multiple frustums existing on the LED screens, but with a slight offset in time. So you can then have multiple cameras capturing multiple frustums, but with a slight offset, so they will only capture the frustum that is specifically rendered for that camera at a very, very short period of time.
Yeah, timing is really the name of the game here.
Yes, indeed.
There's lots of different areas where that comes up, where timing is extremely critical, and Genlock is really just the start of it. Yeah, I think that's some of the core things that we wanted to talk about, at least in this PowerPoint. I think we should kind of get into showing a little bit more about the actual demo that we have here with the environments and what we have.
I'm going to hand the stage over to you, Eli, and I'll be a jib-op.
Thank you. So we were just in the scene, right? So this is, as I mentioned, camera tracking real time, and we can see, as he moves around, that parallax effect that you get with any sort of objects in the environment, because this is a full 3D space. If I wanted to, I can change the origin for this scene, and now I can have another shot where I'm behind this desk. All of that is built, and it's a full 360 environment to explore. Now, one of the things that you may have been noticing is that, while we do have a relatively small LED stage here, you're not seeing the edge of that. And that's part of this XR workflow, which is set extension. This essentially allows us, through calibrations, understanding where the camera is, where the LED is, the camera frustum, we are able to overlay the rest of the environment right where the LED panels actually end. And you'll see I'm actually getting cut off by this AR layer. If I turn it off, we see that's because that's right where the edge of our LED screens are. So Marcus can look up, he can look around, and he has full freedom to explore the entire environment in 360 without necessarily being constrained by the physical size of our LED volume. And so this offers a lot of freedom to people that don't necessarily have a massive LED space, or space to put the LED, or can't get enough LED, or whatever the reason is. It's a very powerful tool that is very commonly seen with XR productions. As we were talking about earlier, that is an AR layer, so that's composited on top of the camera feed, and that of course will not be captured in camera. So again, there's pros and cons to each of those. Now, another thing that we have within this scene that's pretty cool is, it's rendered in real time, which means we can change it and make alterations to it. One of the things that we have in this scenario is some lighting control. So in here, I can go in and, for instance, change the control of the desk behind us, and I can change that to whatever I want. I can have multiple colors. And you're obviously seeing the environment color changing, but we're also seeing that reflected in our lighting fixtures as well, which is a really common thing, is where we have not just the LED panels, they're not often the sole source of light within your environment. You're still utilizing a lot of the existing lighting infrastructure that you would use. So we're sending DMX out to these lighting fixtures with that same color data that we're sending into Unreal Engine to render this color. And of course, you can have a lot of fun with that. And hey, look, I'm not on the green screen. I can actually blast the talent with a bunch of green and not have to worry about it. Not that you'd always want to do that, but it's something to point out there. And just general lighting control is a really important part of this entire workflow. Another thing that we have with this one is the ability to bring in, for instance, real-time rendered characters, or perhaps for a sports broadcast, this might be actual players. A football player can jump into this environment, and now you can read real-time data, and I can reference it, and I can see the character. I can make a natural eye line. Again, a lot of this is really beneficial for the talent. You get much better understanding of the environment and the space that you're in as someone that's actually on there, and there's lots of different interactions that you can have. Now, as I mentioned, this is definitely more broadcast oriented, at least in this scene. So let's jump over to a different environment where we have some additional control. So with the push of a button, I've now transported myself to the other side of the world, to the outback of Australia, where we have again, a lot of similar things that we were talking about earlier with lighting control, one of them being color temperature control. This is something you'll obviously find a lot in really any production, but especially cinematic applications, where you can change the time of day and things like that. And you'll notice that not just the lights in our environment or in our studio here changed, but also the color temperature of the light source within the rendering engine. And with the push of a button, you're able to have that continuity across the entire pipeline there. And then, of course, if I wanted to go in, I can go in and I can adjust the individual lights here if I wanted to. And that's something that you would do once you at least have a baseline. There's a lot of refinement that can happen. And because you can make all these changes in real time, it really isn't a problem. And it's actually a big benefit of putting in the effort in pre-production to be able to do that. Another kind of thing similar to that is, for instance, bringing in objects or moving things within the environment. This is something that a director can go in and say, hey, I want to move that tree, and I want it to now block the road or something like that. That's something where you can go in, move it around, and really affect any value associated with anything within the scene. As I mentioned, time of day is definitely a very popular one. You can go from 4 p.m., you can have 6 hours of golden hour, you can do whatever you want by having this entirely controlled environment, still rendering it at a very high quality. Real-time ray tracing is a very common technology that we see being used, and NVIDIA was one that really started putting it into their graphics cards and allowed that to be used in real-time rendering engines. So ray tracing is being used. Photogrammetry, that's another popular rendering technique or not necessarily a rendering technique, but a texturing technique where you can take hundreds of photos of an object, such as this eucalyptus tree, and you can build that into a very highly detailed mesh and texture that you can put into your environment, so you can get very, very close, or you can just extract a lot of detail out of these scenes. And this environment in particular was actually done entirely through photogrammetry. All of the assets individually were captured independently, then essentially kit bashed all together into this scene that you see here. And once it's in there, you can still make these changes. So lots of flexibility that is offered with this. We do have some other scenes that we can go into, but I think we kind of get the idea of what we're showing right now. And of course, we can go back to this if any questions come up. I think the next thing that we wanted to talk about was a bit around the workflow. How are these things actually connected to each other, and what are the different options that you have there? So with that, I'm going to hand it over to you, Marcus.
Thank you.
Oh,
yeah. So obviously, putting something like this together is not really something that you do with a a laptop from Best Buy and a prosumer camera. As we said before, it does require some pretty high grade enterprise equipment following all the broadcast standards for video transmission, such as Genlock, etc., etc. But if we break this down into its components, this setup that we can see on this slide here is the disguise way of doing it. There are multiple different ways of accomplishing the same thing, but obviously we are showing the way we are doing it. So this setup here really consists of a couple of core elements. If we start in the middle, we have two servers that are labeled VX. So a VX is a server that we provide. They exist in multiple different types. I'm not going to go into that in too much detail, but they are really the hub of this setup. They are receiving all the data from the cameras, the tracking systems, etc., and they are compositing that so that it can be outputted to the LED screens as well as to the program out if necessary. The content that they are receiving is then rendered in real time on a render cluster. So there's no actual rendering happening on these media servers. They are only responsible for compositing the data and outputting it to the LED screens. The render cluster is really where the rendering magic happens. The render cluster can really be scaled from anywhere from one node to essentially as many nodes as you need to accomplish the desired frame rate and resolution and quality of the environment that you're rendering. In between the render cluster and the media servers is a high-speed fiber network, which relies on this fabric switch that we have in between. That is typically a 25 gigabit or 100 gigabit network. The cameras then, they are connected via SDI into the media servers. So that can either be 3G SDI or 12G SDI, depending on the infrastructure. The tracking systems in turn, they are typically transmitting their data over 1 gig or 10 gig Ethernet, just to make sure that there's a very, very low latency connection. And then on the downstream side of the media servers, you typically have a display port, HDMI or SDI based infrastructure. And if we pay a little bit attention to the right hand side, we can see really how the rendering is divided up between the different render nodes. That's just an illustration of the setup that we have here, where we have one render node rendering the outer frustum that we discussed earlier. Two render nodes are sharing the rendering of the hero frustum or the camera frustum. And then we have one dedicated render node for rendering any AR elements that we may have depending on the scene. And once again, this is an example setup using disguise hardware and disguise software. And more than happy to answer any detailed questions about this as well. Next, I think we're
going to be showing the software section of this. So
yeah, exactly. So Eli, with that, please give the audience a little bit of our software.
Yeah, so this is just going to be a very brief overview of how, at least in Disguise, we are managing all of these LED displays, tracking, and render nodes. The core things to note, at least within our software, is we are rendering an exact 3D model of the entire XR stage here. So that includes our LEDs, both our wall, our floor, our side panels. We actually have our lighting fixtures in here as well. And you see that with our camera, with real-time camera tracking on that, we can preview that rendered environment in the background, and we can see that within our 3D visualizer. See, as he pans to the right, we can see how it reveals the outer frustum, and so on. So we can see all of this being previewed here. Then on the bottom, this is where we actually apply content to those LED screens. So in this case, we're using a what we call render stream layer. This is essentially controlling all of the rendering nodes that are being used. We can select the asset remotely, start and stop any number of render nodes. We can choose how big that cluster of render nodes is, and control variables in real time, like what we were showing earlier when I was moving that tree around. That's something where I can control that from this layer. Again, I'm keeping a very high level for here, because there are alternative workflows that aren't exactly like this. But once we have the content and the LED screens, we actually are going to our outputs here. So this is where we can see, in this case over on the left here, this is our HDMI output going to our LED processor. So and then the LED processor is then sending that to the individual LED panels themselves. And this is an HDMI output. But over here, we have an SDI output. So this is a quad SDI output card that allows us to send our program feed to the feed that you're seeing right now, but also be used for additional media playout if we wanted to send it to confidence monitors, if we wanted to do regular video playout that maybe goes back into the real-time rendering engine as a texture in the background. That's something that we can show as well. And yeah, so we also can see the resolution that we're outputting. Oftentimes you might set custom resolutions based on what the LED processor is expecting and the resolution of the LED wall itself. We can also verify the Genlock signal coming in, specify that we're running in 10-bit, and we can also look at the different color spaces that we would be working with. So a lot of control is really needed to manage these types of LED screens and the entire workflow. And at least with us, having it all in a centralized location becomes very beneficial for making it easy for an operator to deal with all the things that operators do often have to deal with, integrating all these different core technologies. But I think talking about the operator is kind of going into what it's like actually on set and during production, during pre-production as well. And that's something where I'm going to hand it over to Marcus to kind of talk about how to manage expectations, how to understand the production, and what that is actually going to be like during an actual shoot. So I'll hand it back over to you.
Thank you. Yeah, exactly. And as you may have realized by now, we are literally rewriting the playbook of content production with XR and virtual productions. Like there's very, very few things that we do that is done in a classical way when doing this. As we mentioned before, there are some requirements on the camera side. Obviously, introducing an LED screen on any film or broadcast studio is always going to make people ask some questions. But I think the most important aspect of all these things that I would like to bring up is really the collaboration between different departments. Traditionally, you may have different departments on a production working almost in silo or in isolation between each other. They don't really need to collaborate or communicate a lot, but with XR, that is really, really changing. It is imperative that there is clear communication between the screens production team, the camera department, the engineering department, and everything in between. Just to make sure that people know exactly what to expect, as well as what they can and cannot do. And when I say can and cannot do, it's not that I want to tell people that you cannot do this, but I think it's important to understand what are the repercussions of certain decisions that people may make. As an example, as we mentioned before, when setting something like this up, it's really crucial that everything is calibrated, both when it comes to like the timing of the entire system, but also the spatial calibration and as well as the lens profiling. Part of being able to do this is for the XR system to know exactly how to virtually reproduce what the lens is seeing. So for the set extension, for example, we need to simulate exactly what the lens optically is doing to the footage that it's capturing. And part of that is being able then to capture and calculate lens data in real time. If you were to swap the lens on the camera, that will need a recalibration of the system. So being aware of those aspects is really, really important because it will affect the timeline of your production. Same thing there with certain camera movement, etc., that may, for example, cause decapitation by set extension. That is actually not something that is entirely uncommon. If you see this kind of stage that we have here, obviously there's very little risk of that happening, but it is possible for me to walk outside of the area where the camera is capturing me if I don't know that there is set extension there and that this region of the LED screen is covered by that set extension. So once again, it's all about managing expectations and clearly communicating what is possible, and the fact that this is an amazing toolkit and an amazing powerful content creation tool, but it does come with certain changes to established rules and workflows. And I think by that, it is time for to dig into some Q&A. I don't know if we've had any questions in the chat during the presentation. If we have, then Tim, feel free to send them our way. If not, I'm more than happy to take them in real time.
Yeah, there's at least one comment here. I think Patty would like to see a multi-camera demo if you're able to do that. I know you said it was a little complicated and such. And
yeah, we don't have two cameras set up here, unfortunately. We only have one camera. It's definitely something that we'd be happy to set up at a different point in time, but tonight we're unfortunately not equipped to be able to do that.
Okay. Yeah, and I had a question as well. I see you guys are, you're on your LED set now.
Hmm?
Are there algorithms that will account for your shadows that could be created and should be on the street? How does shadows work for tracking people on set?
To a certain extent, there will be natural shadow casting just by the fact that we're using practical lighting fixture as well. So if you look carefully, there will be a shadow cast here from the lights that I have. However, there are topics such as virtual shadow inclusion and exclusion, which will have to be done inside the render engine. There are established workflows on how to accomplish that. It's not something that I have set up here because it does require some additional equipment, but it's entirely possible to do.
I'd also like to add on top of that is kind of the conversation when we're talking about an LED floor, which is emissive and of course makes it very difficult to get shadows casted even by these very bright lights. But when we're talking about these film virtual productions, they are typically using practical floor elements on top of and not using LED, right? So in that case, I think I actually have a quick picture I can show of this, where we have foliage in the foreground, trees, things like that, but no LED. So all the lighting that you are casting on your talent is producing real accurate shadows on the real environment that they're actually standing on. But as Marcus mentioned, it does become a lot more technically challenging when you do need to interact that with LEDs. But that is something that's been seeing a lot of attention, and there are a number of solutions that people are in the prototype phase of that seem pretty promising.
Yeah.
Okay, we've got a couple other questions. Thanks for answering that one. Going back to the multi-camera, the question is that how you do concerts?
Well, concerts are typically not done in an XR setup, or you think about a live concert or a concert in extended reality, because there are obviously both.
Yeah, Patty, feel free to unmute yourself and ask the question. Or maybe she can't. She says live in the chat. So just think about live.
Okay, yeah. So if it's a live to air or even live to tape XR broadcast with a musical production, then yes, it is typically done with multiple cameras, and there's a traditional switching infrastructure downstream of the XR. system, but the actual camera cutting, the actual physical cut between two cameras happens inside the XR system traditionally. And Eli, with your broadcast background, you can probably add some additional details to that workflow.
Yeah, for sure. So in a scenario like that, you would still have your switcher where you have your 2 or 3 cameras on top of whatever other, other color cameras or any additional feeds that you might have that are non-XR. But when you switch between those cameras, you'll be sending some sort of signal into Disguise. That really depends on the switcher, what signals are available. But you would send that signal to whatever XR production system is being used. Then it is actually doing the camera switch internally, both switching the video feed of the cameras, but also, as we mentioned, in real time, at that exact same time, switching the content that's in the background.
Yep.
However, if you're working in a scenario like Marcus was mentioning earlier with multiple camera frustums being overlaid onto the same section of LED with either frame remapping or what's called ghost frame technology, that's a scenario where you're actually just receiving your ISO feeds, and that is something that is, you don't need to send any command at all. You're just switching between 2 different video cameras. So there are different workflows that exist out there. There's also the idea that because your final pixel essentially is going out of the XR system, you might use like an iPad interface here, like we've been using this to control the entire production here. I can just as easily send a command to switch between cameras if the final result is going right out of that XR system, which is exactly what we're doing right now.
Exactly. But you can still fit into an existing broadcast infrastructure for like applying lower thirds, et cetera,
Yeah.
on the outgoing program feed from the XR system.
Thank you. We've got another question about how portable are the stages for concerts?
So we rarely see these stages being used in a portable manner. So if you think about a live concert, like in a stadium or in an arena, that is typically not an XR stage. It may have certain AR elements to it that are then rendered on top of the broadcast feed, but typically you don't see a portable XR stage. The reason why is it's a very, very complex operation to put it together, calibrate all the different systems that need to be calibrated, and it's typically something that takes at least a couple of days, if not a week, typically to put all of that together, and there's just not enough time to do that when you're when you're touring. As an example, putting this together took us roughly a week and a half or something like that, building it all and recalibrating the tracking system. You may potentially have to LiDAR scan the LED stage, depending on the complexity of that, and so on and so forth. So typically in a live show or live concert scenario, you may see large LED screens, but they are typically not part of a traditional XR workflow. They are just displaying content that is not rendered from the perspective of a camera.
Yeah, I think one more thing to add on top of that, at least for the live space, is that it is likely that you are going to see more and more LED being used in these environments, like you were saying, but also you may not be rendering it from the camera's perspective, but I think real-time rendering, having taking the capture from a person standing on there, feeding that into the rendering engine, and then having particle effects on top of that, or some sort of image distortion in real time. That is something that we are definitely seeing a lot of interest for going on tour. But XR, again, kind of tying it to the camera with the stage, that is not something that we are really seeing being on tour, for the reasons that you just mentioned.
Okay, thank you. I got another question came in. Is it ever distracting to the talent to see elements of the background moving behind them in response to camera movement, even though those elements should be stationary to them?
Personally, I mean, both Eli and myself, we've spent countless hours on this stage. So for us, no, not at all. Typically what you see, and I've spent a fair amount of time on actual live productions, and typically when talent walks up on stage, and they see the background moving when the camera is moving, it creates sometimes a very humoristic effect that they react. It's like, oh, what's going on here? But they kind of catch on almost immediately, and they understand what's going on, and then they can use it to their benefits instead. So it's distracting maybe for 30 seconds before they kind of understand what's going on and how to use it to augment their performance.
Yeah, I mean, I agree. I mean, I've also worked a lot on green screens, and I definitely prefer this. It's a lot better for the talent to understand where they are.
Yeah.
And as Marcus was saying, is right. You know, we do a lot of in-person demos with this and on our stage, and so we've seen a lot of people that have never seen one of these in person get on one, see that interaction, and there is that initial shock, and there is that kind of reaction to it that's like, whoa, this is like nothing I've ever seen before, because it isn't. But people get used to it very quickly, and
I think that really brings up one of the benefits to this as a production technology, right? Green screen with its inherently kind of nauseating way of if you're on a green screen, it's nauseating. You don't really know what you're doing, and you don't really know what you're interacting with. Maybe you have some tennis balls up in the air for your eye lines, etc. So for people that haven't received any media training and are not used to acting in front of a green screen, this feels very, very natural. And I think that's why we see these applications being very common in like sports broadcasts, corporate environment, etc., where you have executives and sports people who are not really used to being in a green screen environment because they haven't really received any acting training or media training.
Okay. We got the next question from Garrick. Does the system need to use specific cameras?
Not specific camera models or specific camera manufacturers. There are some technical requirements on the cameras that will definitely make life easier for you. As I mentioned earlier, the fact that the camera needs to be able to gen lock, that is a given. It is also needs to be working in progressive signals. Apart from those two, there's really no other hard requirements on the camera. It can be of essentially any manufacturer, any brand that can output a progressive SDI signal that is able to gen lock. But there will certain things that will make life easier for you, such as using a global shutter, or if you're using a rolling shutter sensor, then having a fast rolling shutter is definitely preferable to counteract some of the optical phenomena that may happen otherwise. But other than that, it's pretty much fair game.
All right, thank you. We've got one more question from Ken. What happens if you feed a camera into the LED display? What does the video feedback look like in your environment?
That's actually a really good question. And I mean, we can bring up one environment. We can actually do that in real time. So if you bring up the Frey environment, I can fix the SDI feed.
Yeah, you want to do that?
Yeah, sure. So yeah, that there is just that's just a still that we showed earlier. But I can definitely, let's see here. I'm gonna put Eli on hold for a little bit. So please forgive me while I am messing this up.
Yeah, I broke it.
No, not at all. I'm just on hold. See here. All.
So actually, I kind of want to talk about this hold feature because it looks kind of weird on the program output, but one of the things that I'm seeing inside this space here is still content on the LED. So this is something where if you do need to make changes to the environment, you know, the Unreal or whatever scene that you're working with, this is something where you can hold your outputs. So you still have content on the LED, but you stop your rendering engines, you make changes in the editor, And while that's still going, you still have content for blocking. You can, oh, there he goes. Why am I upside down?
Yeah, there we go.
There you go, Ken.
Thank you. This is wonderful.
This is great.
Glad we could be of service. We can obviously bring in the witness camera here instead, and maybe that makes more
I don't know if
sense.
that's going to be better.
Um,
I guess it upside down.
and let me just rotate it as well,
Oh, yeah.
so that it's actually. There we go. How's that?
Yeah, there it is. So you talked about latency earlier in this being, I think the quote was a game of latency. What is the latency, you know, generally from, what's the latency that we're talking about here?
It depends a little bit on the system setup. We typically see an end-to-end latency of about 7 frames. And when we say end-to-end latency, it means from the moment in time where the camera starts to move, that information being sent into the XR system, a frame is rendered, and then that frame is being outputted on the LED screen and then captured again by the camera. That is typically 7 frames.
Okay, all right. Let's see, let's see if another question came in here. There you go. I think that's concluding it. We've got one more thing here. Wait, so Garrick, yes, I will be posting the recording of this video on the Sacramento SMPTE YouTube site. If you would like to email me or type in your email address into the chat, I'll make sure I send that link to you. On that note, I'd like to thank Disguise, and I'd like to thank Eli and Marcus for this wonderful presentation about extended reality and virtual reality productions. It was enlightening for me and exciting to see this technology. You know, I've seen a lot of it on the shows that I watch and stuff, but haven't had the behind the scenes scoop on the technology and the tools that it takes to actually put it together. So I thank you for your time and expertise.
Yes, thank you very much.
Thank you. Thank you all.
Yeah, thanks for having us. This was great.
Absolutely. Take care.
And yeah, as was mentioned earlier, our office is in downtown LA. So if you ever happen to drive past LA, you're more than welcome to give us a ring, and we're happy to show you this in person as well.
Sounds great. Appreciate that. Okay, on behalf of our chapter, I say thank you and good night.
Thank you and good night.
Great presentation. Really excellent. Thank you.
Thank you.
Thank you.